You're listening to Data Science Leaders, the premier podcast for executives tackling the world's most important challenges using the power of machine learning. Let's dive in. Hello and welcome to our discussion about shattering the myths of generative AI, where we will talk about the most pernicious myths that are setting folks up for failure, preventing folks from delivering impact with generative AI, and talk about what they should be doing instead. My name is Shel Carlson. I'm head of AI strategy here at Domino Data Lab. But more importantly, we are joined by Rowan Curran, the industry analyst at Forrester Research, who spearheads their research on generative AI. Rowan, thank you very much for joining us.
Thank you so much for having me back. I'm really excited to have our conversation today.
Wonderful. Well, let's start with setting the stage. Why do we even really need to talk about the myths? Are they that important? Are they that pernicious?
Yeah, so I think that in the explosion of what was initially hype, and now I would say is a boom around generative AI over the past year, it's a new set of models, a new technology space for a lot of folks. And because of that, there's a lot of misconceptions, a lot of confusions that have led to myths being constructed and perpetuated that really are, restraining the way that people can advance their enterprise projects and even, restraining the way that they're actually thinking about the technology itself. And it's not just, creating confusions about generative AI, but it's also creating confusions about the broader ecosystems they're working within.
Yeah, arguably, we've had myths of AI and machine learning that we've just barely started to overcome, like the good old ones about, unsupervised machine learning, that doesn't require people, right? Or the ones of, models automatically learn over time and get better. It's like, not usually. But this is a new set of myths. And is this one of those areas where folks had just actually gotten over those past myths and now all of a sudden are falling into new traps? Or is it mostly?
Oh, no, I would say this is compounding the issues that we've had before. So I think, one of the biggest things that I've seen is that as people are getting really excited about generative AI, they're, folding in everything they have ever heard about AI more broadly, and then creating, these really, deep-seated confusions that, I honestly spend a lot of my time trying to help, business, both leaders and practitioners disambiguate.
I would love to get your sense of, where would you start? What is the biggest myth that you find yourself confronting over and over again?
So I wouldn't say it's necessarily the biggest myth, but I think it's a good place for us to start. And that is when I see folks conflating generative AI with the broader AI space. And that's coming from, the fact that generative AI started to come and dominate the conversation. And we haven't had a really good language to talk about everything that's kind of come before. Now, the way that I have been discussing this with folks is by building, it's a mental model. It's not a true taxonomy, by breaking up generative AI as opposed to predictive AI. And the way that I think about this and the way I try to help folks understand this is when you're thinking about predictive AI, you can broadly think about just predicting one thing or, a very small set. So say you're trying to predict whether a customer is going to churn, or you're trying to understand, whether somebody fits into a particular cluster or a segment or something like that, or you're trying to make a specific decision in an optimization algorithm. As opposed to generative AI, where they're similar, models broadly, but what we're creating is actually a whole data set. And that data set could be a bunch of natural language text, it could be code, it could be images, it could be video. But generally, it's about taking data, training a model with it, and predicting a larger data set. Now, there's other differences between them that are important to talk about as well. So currently, generative AI is not very well suited for the analysis of structured data, particularly if you are analyzing at the core. Now, we can talk a bit about how people are starting to overcome this in certain ways. Like some folks are using other types of machine readable language, like putting math into JSON, for example, and then having the language model read that as language as opposed to a table or mathematical statements. But really, most of the structured insights and analysis are still coming from more of this predictive AI side, because that's where we can really do things, with data that is in tables or in arrays or other types of data structures that we can't quite use generative AI for broadly, and especially not large language models at this point in time. Now, there is an ongoing conversation about whether this is even possible to do. So we've obviously seen, continued advancements in the language models released this year, various claims about getting better at, certain types of math. But I think for the vast majority of use cases, and for most people who are going to be listening to this podcast, for now, it's important to keep kind of generative AI more in the unstructured data side, and the structured data more on the predictive side. Now, you can do things to blend these in the presentation, the delivery of insights, but when you're actually thinking about analyzing the underlying data and the content, keeping these kind of separated in your mind is a good way to start thinking about it, and also is a very good way to start communicating with your business stakeholders around this. Because another one of these issues when people conflate these two things is that they'll come up with use cases, and these use cases they'll present them and saying, I need generative AI to tell me which of my customers are not going to come to our website next year. Well, okay, that's great. I understand you need an application to do that, but a generative AI application is not actually going to be the best solution to that problem. Aside from the fact that it's probably not actually going to answer the question that you want to, and is definitely not going to answer it reliably, it's also going to cost way more to get that insight that is useless than it is to, create a model or even get any of these, many, many off-the-shelf models for a lot of these, well-known problems to attack this. So as tech leaders, having many, more enthusiastic business folks about AI in this past year, it's important to help them understand the basics of this so that you can really tap into their enthusiasm and focus on the use cases that are actually realistic, and also that you'll match up the use cases to their expectations of what is actually possible with this technology today.
Hey, so it sounds like there were several things that you were covering there. One of them was the different aspects of how generative AI is different from predictive AI. And it sounded like one of those was just in terms of the specialized or specific nature of it. Usually predictive AI models tend to be a lot more focused on one individual task, versus generative AI models are particularly good at being used for multiple different tasks, potentially sometimes simultaneously. One of those elements was also on the structured versus unstructured nature of the data. Generative AI models generally being better when it comes to both processing and creating unstructured data, versus predictive AI models more traditionally being better on for analyzing structured data and potentially even generating structured data, although that seems to be kind of in flux. But there's also the element of the technology underpinning this too, right? In terms of when we're talking about generative AI, yes, we've had traditional generative AI techniques, but really the new kid on the block here, the thing that everyone's excited about, are these large language models or transformer encoder-decoder networks that we didn't have before. The 2017, prior to that, we did not have wonderful techniques for going in and analyzing this unstructured data or generating them. Versus when we refer to predictive AI, we're really referring to a huge swath of different tools and technology. How about the this issue of that there would be some sort of hierarchy of them, that there would be better ones or worse ones, that we should be leveraging generative AI because generative AI is better, or because generative AI replaces those other methods? Is that another myth that you're seeing, or one that we need to tackle?
So I think what we need to approach with this is that generative AI is better and more efficient for some tasks, but we can't just kind of blanket say it's better for all of these tasks within this particular domain. So there's a lot of tasks, say, in the language processing domain, where using a large language model can take the place of a bunch of smaller specialized models that can be very challenging and expensive for teams to build. So we're seeing a lot of folks kind of use it in that way. But I think that it's also important to keep in mind that as we are using large language models, there's some circumstances where you might not actually want or need to use it. So say if you're using it in a chatbot type of scenario, which is kind of the classic scenario, even though that's one of the more, I would say, banal ones at this point, you might not necessarily have to use a large language model to build that interaction if it's a very simplistic interaction. Say, it's a chatbot that's really only supposed to answer like 5 or 10 different questions, and you have highly curated data set. It might actually make more sense for you to just build a very simple dialogue tree around that and not go to the trouble of using a language model integrated into that situation. Now, it's a very small example, but I think it plays out more broadly. And then when you get into, okay, we've decided that, it makes sense to use a large language model within this context. When you take that step, then you enter a whole new world of questions of how do we actually decide which model to use, not just what model is going to perform the best for the task that we have chosen, but also what model performs that most efficiently based upon our costs and our architecture and all this type of stuff.
Yeah, I jokingly say that ChatGPT was the first and last pure generative AI application. And what I mean by that is that even for use cases that are language use cases, it's almost always the case that you're going to be able to drive efficiency by decomposing that problem. And so that the large language model is just actually doing what it is best on. So taking that chatbot example, yes, you could do the intent recognition, the topic modeling, the case classification with the large language model, but likely it's going to be less accurate and certainly much more costly and less efficient than doing that with a smaller BERT-style model that you fine-tuned on your historical data to go after that. Or similarly, if you're predicting what the next best action is to be doing, you might pull that one out as well. Yes, you could get the large language model to do it, but again, you might choose to pull that out because you can use either historical data that you don't want to share with a third party, and again, because maybe you're able to get it at a higher accuracy, or just be cheaper. And then you're using the large language model at the end in order to provide the text wrapper, provide that interactivity, provide the follow-up, and so on and so forth. But are you seeing that as well, or is that less of a clear trend yet?
So partially, and I'll go for a couple of things that you brought up there. So I think the first point around ChatGPT being kind of the last pure generative AI application. So even if we're talking about ChatGPT, that is not just a large language model. Like if you just interact with the,
you called me on it. Even they are not.
Well, but I think this is I think it's a great point to bring up because I think for, so many of the folks out there, we do just think about ChatGPT as just a generative application, a generative model without really anything around it. When even if we're talking about the initial release version, there were additional layers in terms of, using a system prompt, monitoring the output for toxicity and things like that were going into the construction of that application, and even things like designing the chat interface itself with the historical chats on the left-hand side. Those are all, software development and user experience pieces that led to us really actually engaging with this thing super deeply. Because, if you went and used the 3.5 models on the playground, they are much more raw. They do not behave in the same way as ChatGPT. So I think in any type of, thought around how are we going to, use these things, we need to think about not just the model itself, but what are we actually going to build around it in order to focus the behavior of the model.
Oh, so it sounds like there's a myth in here about that an LLM is all you need. It's actually, in order to create a generative AI application, you need a lot of different technology components, some of them potentially machine learning and AI ones, but at the very least, you're going to need a whole host of more traditional software components in order to turn this into a meaningful application.
Yeah, absolutely. And I think you kind of were starting to allude to this before in terms of the generation of the output for the end user with the large language model. But, really what we're seeing, especially if we're thinking about applications that are using something like, let's say, retrieval augmented generation, which is, I would say, the most common architecture that I'm seeing right now for generative AI applications that are designed for any type of knowledge delivery or knowledge retrieval. There's plenty of use cases where folks are not using retrieval augmented generation for productivity and writing assistance use cases and things like that. But really, this is how folks are, this is the main architecture that I'm seeing for folks to ground the behavior of the model in their knowledge and actually, focus it in on the behaviors that they want. And so what this is involving is oftentimes, it's involving two iterations of a model, and that could either be two of the same model or it could be multiple models. So as you alluded to before, you might use BERT to understand the intent of the user as they are coming in and entering their query. And then what you would do is you have something on the back end. Oftentimes it's a vector database, though I've certainly seen people do a RAG-like architecture using a more standard lexical or keyword index on the back end, and you're just using the initial language model to break that into a couple keyword queries. And then that content is brought back. You use some kind of, hopefully, a retrieval ranker, so some stuff from the search space to make sure you are retrieving the most relevant content and ranking it appropriately, because you might have a corpus of, let's say, when we're talking about the enterprise, tens of thousands or even hundreds of millions of documents or other types of content you're trying to return. So having the right one show up first is very important. And then you'd have another language model that would take the content that was brought back, usually in chunks, or what are called chunks. So basically, you take a longer document, you break it down into smaller pieces so that it can be consumed by the model, but you give all that back to the model, and then it generates an answer for the end user. So there's multiple different pieces of software in there, and that's even not and that's just the back-end software. We're not even really talking about the whole user experience. We're not talking about additional components of understanding the user intent that you could be giving to the model. So things like understanding the user's location or the demographic if you're doing segmentation on your website, say using predictive AI in combination with generative AI, which is oftentimes where we see kind of the best outcomes. But really using these additional pieces allows you to focus in the behavior of the model when you're generating or when you're seeking to generate the answer, and then also to make sure that the answer is grounded more in reality and in the ground truth that you are trying to focus on. And then you can, even go farther with that, where we have seen some folks actually run the output through another language model that tries to basically match the sentences that are generated with the originating content so that you can have citations that go to specific points in that generated content rather than just, a little like a set of references at the end, as, we see in a lot of the simpler implementations. But this overall, involves some known components like the segmentation and some of the intent understanding, but then also, this involves areas that folks may not have a lot of understanding in. So how do I build a vector database? How do I think about embeddings and chunkings and stuff like this? There's a lot of stuff that is, known and more of like a better described space. And then there's things that are not necessarily totally new to the landscape, but a lot of developers and data science who are going to be working with this are going to have to start learning about these adjacent areas as well.
I did want to ask about something you touched on before, about the data scientists and developers. Who is the best person to go in and take the lead on the creation of this? Because as you mentioned, there are a lot of unknown components in this that, whether you're a data scientist or a developer, you've never really seen before. I mean, even most data scientists would not have been familiar with vector databases, indeed, very few data scientists were trained on BERT-style models, let alone leveraging large language models. Are you seeing that there are, so everybody has to learn this, but does anybody have a natural advantage coming into this? Is this something that developers can come in and view this, this is really just like a traditional application, and thus, it's just a question of learning how to use the API and things like that? Or is this one where the data scientist or the data science team is best at going in and leading the construction of this, because they're used to working with ad hoc data pipelines, solving unknown problems that haven't really been tackled previously, learning about these models and how to control these models and evaluate them? What are you seeing as a best practice?
So I think that really heavily depends on how folks are looking at deploying this stuff. So I think if we are talking about folks that want to interact with the model directly, say bring an open source model on premises, maybe think about either doing fine tuning eventually or thinking about an instruction tuning data set, though obviously that is a much lower proportion of folks that are doing that today. I think that data scientists do have a bit of an advantage in terms of just having worked with that type of complexity when it comes to models before in time, and kind of needing to deal with some of the operationalization, particularly around deploying models. Now, that specifically goes for data scientists who are used to actually releasing models into production, because I don't necessarily think that data scientists who are only involved in model building and have only been involved in model building in the past have a strict advantage over developers when starting to work with this stuff. Because
and applied statisticians probably even less so.
Yes.
So
yeah.
My old background would not have served me well here. But it sounds like what you're describing is really the ML engineer. Now, obviously, unfortunately, that term, again, there's a lot of confusion around what exactly it means. But to the extent that the ML engineer was a person who was very much involved with productionizing models and very much involved with the ongoing monitoring of them and creating those pipelines around them, that is really the ideal person if you can find them or have them to start with, it sounds like.
I don't know what to start with, but I do think that they are an essential component of building especially any type of pipeline around this that is going to involve open source models that you're going to need to actually kind of monitor more of the behavior more closely than, say, one of these cloud-based API services. I do think that in that circumstance, it's very important to have the MLOps folks heavily involved. Now, I think that it's also very important to have folks who are not necessarily involved in the analytics or data science space, because when we're talking about interacting with the models themselves, that is not the same paradigm that data scientists or even developers are usually used to interacting with software. Like using natural language to communicate, that is not generally how, engineers have been trained to communicate. And honestly, I think that some of the things that we have been trained to do can actually restrict us in how, quickly we can start to spin up on some of these things. Now, a lot of people have started to overcome them, but one of the big things earlier this year was really trying to, kind of shift developers thinking around, okay, usually we're just thinking about kind of non-determinate or deterministic outputs. Like I put this thing in, it goes into the flow, and then I get this output, and it's easily testable, and we can iterate on this. Whereas when they're starting to work with, large language models and predictive AI, even, it's a much more ambiguous type of situation. So you have to design your application in a slightly different way. And I think that also when it comes to, data scientists usually have access to the data set that is being used to create the model that they're dealing with. So there's some way that they can start to interrogate and understand what is going on. But when it comes to large language models, it's a much different activity in order to try and determine why certain behaviors happen. Because, this is true of all deep learning models, but especially with, transformers of this scale, you cannot look at what all the connections were between the different neurons to actually create a certain feature or parameter, insight, or something like that. So I think that change can, from some of the folks that I've talked to has they get over it, but it's a little bit of a mind shift that has to happen around this. So I do think that you bring this up as a very good point, though, because I think that data scientists have been a little bit neglected in terms of their importance to the long-term success of this over the course of the past year. But I do also think that it's important for us to look at the data science role as perhaps needing to continue to change and evolve with this. So, data scientists who might have in the past said, I only deal with structured data and I only deal with things that are, hard math and things like that. They may have to start thinking about, how do I work with unstructured data, even if it's how do I actually, work with these models to extract some kind of generation or something like that. But additionally, I just wanted to add on one more piece of this. And I think that one challenge that I have, or not one challenge, but one opportunity and gap I think I've seen around the data science space this year is that there's been a ton of attention and focus on developers using generative tools for code creation. Whereas I've seen some discussion, but I haven't seen as much evangelization. I haven't seen as much activity in the data science community around using these things, whether it be, ChatGPT or BART or any of the other commercial models or any of the things like Code Whisper, whatnot, specifically designed for this to help them generate code for models, or even to help deploy models into production, for example. That is a great use case for this stuff to help me build a Docker container so that I actually can put my model into production. So I think there's a couple of components of how data science can take advantage of this, but also I think that the data science community could do with being being made a bit more excited about what the potential for them is in using these models, not just in terms of in production, but actually using them to help do their core work better.
Oh, absolutely. I'm holding myself back from talking about what we're doing on the Domino side in terms of leveraging generative AI models to go in and facilitate the data scientists, make the data scientists more productive, and so on and so forth. But just going back, I felt like there are almost like two myths in there. So one of the myths is that you don't need any data science when it comes to generative AI. You absolutely do for a lot of different use cases, but similarly, it would be a myth to say that data science is either always needed or traditional data science is what will guarantee you success with generative AI. The data science field, it's a very particular a specialized type of data science that a lot of data scientists aren't trained on. And there are a lot of use cases where potentially there's less need or involvement in them because of the particular use case that you're going after.
Yeah, well, I think the thing is that when we're talking about the data science involvement here, it's not going to be like most data scientists at companies are going to build their own transformer from scratch to do whatever. It's a very different activity of either, doing prompt engineering and stuff like that, which is basically outside of the model itself, but trying to make the model behave in a certain way, or it's fine-tuning the model, which is, just adjusting the model to the behavior, hoping that you have enough data kind of to redirect it in a certain direction. And that's very different from the way that most data scientists have done their jobs in the past and have had the expectation of what they can do with the models.
Well, to a certain extent, it was sort of like the mischaracterization of the data scientist role as being primarily about developing models, where, I mean, it's always been like you'd be lucky if you got to spend more than 10% of your or 20% of your time actually going and developing models. Vast majority of it is everything that's outside it. And it sounds like, yeah, that's the same thing that's going to happen here. It's just that all of the stuff that's surrounding it is going to be different from what you were doing previously.
Yes. You're probably not going to spend, 30 of your 40 hours a week, looking for the precise data set to, build your model or making sure you have access to it. But you might be spending that time, sending, 500 different prompts at a model, trying to test certain types of behavior, or, working in an environment where you are testing a prompt against, 15 different models to understand how they all respond to a specific prompt, what the latency is, and things like that. So it's a similar set of additional side tasks, but it's a different set as well. Yeah.
I like to think that it'll be a lot more interesting, but at the same time, I think it's going to be just as frustrating as it was previously, given the inconsistency when it comes to prompts. But I do want to go into the prompts, because a lot of folks have immediately rushed out and said, okay, so I need to train everybody on prompt engineering, and I need to hire a bunch of prompt engineers. What is your sense of that as a myth? Is there truth? Where is there truth in it, to the extent that there is, and where does it start to fall apart?
Yeah, so I think that's a great question. I think that a good way to think about this is when we look at the prompt engineering space is similar to the way that we might look at any other type of querying space. So, and today we're probably not going to need to hire prompt engineers, especially because there's only very specialized circumstances that you would have enough work for those folks to do for it to actually make sense. Additionally, the actual process and activity of prompt engineering is continuously evolving. So, 4 or 5 months ago, we didn't have any models that had context windows that were over, 100,000 tokens. And now we have several. And when we get to context windows of that size, prompt engineering again enters a kind of whole new realm. So previously, people were using prompt engineering and single shot or multi-shot or multi-pass learning with these models to really focus the behavior in, because they would not forget things that were in the prompt itself. What we've started to see in these much longer prompts is that when you get to so I think I saw one for an analysis for Claude that was basically looking at how at about 7% of the way into a 200-page prompt to about 23% of the way through, the model just kind of wandered off and was not able to recall facts within that window. So this was not a problem or a challenge just a few months ago, and so there's not solutions to it yet today, and so the process of prompt engineering is continuously, changing and will evolve over the next, X number of years. Now, what this means is that, it's very important for all of us to understand the basics of prompting, because even if we are just interacting, say, with the very end point of, some type of assistant or chatbot or something like that, we're going to need to know how to query it. Now, there's going to be a bunch of other stuff that's going on in the background where the either application developers or data scientists as part of the process have done things like create a system prompt, which basically focuses the behavior on a particular topic area. But we as the end user are still going to need to know how to ask it questions in certain ways. But when we get closer to the actual application and model behavior development experience, that's when prompt engineering is going to come to the fore a lot more. But I do think it's very important to keep this kind of evolving. It's an evolving discipline in mind as we approach it. That, if you are going to have somebody who's responsible for prompt engineering, the characteristics that you're going to want from them is not necessarily that they know how to do like every best practice in prompting today. You're going to want to have somebody who's really inquisitive, really, wants to challenge themselves and explore, and who is willing to change their mind over time about what the best practice is. Because especially when we think about prompt engineering, it's not just, it's not an isolated activity. So similarly to how we were talking about, the associated data scientist activity, prompt engineers need to consider the entire pipeline around their prompt and how that's going to affect the rest of the pipeline when they make changes or update something. So this particularly becomes a more challenging problem when we have more advanced applications that are using either, some kind of plan and solve reasoning where you ask a model to do something, it comes up with a plan, and then it iterates through it to execute it. Or if you have multiple models that are, dealing with a prompt and then creating a generation in a single flow, and, one change somewhere in the pipeline could affect how an output occurs somewhere else. That is, definitely a prompt engineering activity, but there's not experts in prompt engineering as a broad kind of contiguous practice. There are people who are really good at it today and who are innovating in the space and really bringing the art and science of this forward. And it is a really interesting combination of art and science, which is an important thing to keep in mind, is it's inherently language-based, and language is ambiguous. And so it's never going to be this is the definite best thing to do everywhere. And then particularly, and I'll just close it off on this, not all models are created equal or respond the same. So what works really well for engineering against, let's say, Falcon T5 or something like that is not necessarily going to work for Claude 2 or GPT-4 or some of these others. So when we're thinking about prompt engineering, it's a case by case in terms of the model activity, but it's also a case by case activity in terms of what use case you're applying it to. So all that is to say, hiring a prompt engineer, maybe not necessarily the greatest idea today, but there's a lot of work to be done in the activity of prompt engineering when you are starting to build these applications.
I mean, so prompt engineering itself is extremely important and something that we're going to have to be focusing on. But it sounds almost like, well, the notion of expertise in prompt engineering is a little bit of an oxymoron because what you need to do will be massively changing because as the models change, but also because the kinds of prompts that you would be using will change depending on the task and the application that you're going after, and also because it'll vary even depending on the type of model that you're using, what kind of syntax you would use. So the degree of transferable expertise that you can have around prompt engineering is currently a little bit limited. But that being said, prompt engineering itself is extraordinarily powerful, and we'll need to be doing a lot of it. It just is going to be very trial and error focused and very experiment. We're going to have to experiment and iterate our way towards it.
Yeah, so I think it's a really great point about the experimental nature of it. I think on the expertise side, I think the way to look at this is if you took a course on prompt engineering that started today and ended in a month, by the time you got to the end of that month, some of the practices that were good to have as part of that curriculum right now are probably not going to be super relevant. So I think the expertise comes from, a lot of the similar data science expertise and developer expertise is just being curious and highly adaptable and willing to adjust your expectations and honest. And as you said, a lot of this stuff is, it comes down to manual testing. At this point, there's more automation that's coming in as more and more folks are developing capabilities, but there's no kind of permanent state. There's no certificate program that you're going to go to that is going to be all right, I'm a great prompt engineer and now I can just go and I don't have to spend a good amount of my time, with kind of continuous learning. Right now, the continuous learning is kind of the standard and how you get to the state of the art right now.
Well, it makes me think that if we were to summarize all of the myths that we're talking about right now, myth number one would be there is no easy button with generative AI, both in terms of that generative AI could solve everything for you, but also even in terms of when you're developing a Gen AI application, a lot of these things are going to involve quite a lot of work for now, at least. So, watch this space.
Yeah, and I think that's it. I mean, that speaks to how we've seen people start to adopt generative AI at scale. earlier this year, a lot of folks were like, yes, we're going to get our own model. We're going to fine tune it. It's going to be awesome. And then they found out how hard that was. And then they were like, okay, well, we were going to get our own model. We're going to use it. We want the vendors to provide us with the different options to embed whatever model in an endpoint application. And the vendors did that. But I haven't seen as many people as claimed they would want to actually bring their own model actually doing that today. So, there's a lot of ways to go about this and a lot of work to be done in various areas. But I think, it's very easy to have an idea and to get started in generative AI. It's very hard to get going, especially when we're talking about getting going in terms of, putting models into production that you have risk control on and other aspects that you need in an enterprise context.
Well, I guess I wanted to touch on that topic of LLMOps. To what degree is this an entirely new thing, and how does it interact with MLOps? I'm imagining we're going to come to the conclusion that, well, it'd be a myth that they're the same thing, and they're the myth that they're entirely different, that they don't have anything to do with each other. But what's your view on it?
Yeah, so the LLMOps question it's a delightful one for me because it's something that I have I saw pop up. I would say April, May, June timeframe, and since then I've really been having discussions with various smart folks about what do we think about this. And my view that has been heavily filtered through a lot of these other experts that I've been talking to is that LLM ops as a conceptual area is helpful right now in terms of trying to communicate to some folks, particularly a lot of these folks that are coming to the broader AI space, via the excitement around generative AI. They have not really had a conception, and they certainly don't have an MLOps practice. So there's not a good understanding of, we need to continuously monitor, update these things, and make sure that they're performing right over time. Now, that doesn't mean that a discipline of LLM ops actually makes sense to describe in the mid and long term. I think what we see now, especially in terms of the way people are starting to release products and capabilities around this, is that while some people are keeping the operations of the large language models separate, a lot of them are basically just adding new ways of describing metrics, ways of describing goals in their model ops capabilities, and just using that just applying that to large language models. And then I think that this is, honestly, the better long-term approach, because then we're not kind of creating this weird silo of LLM ops that is separate from model ops or ML ops. Because ultimately, these applications, as we've discussed right at the top, they're going to be using both predictive AI, they're going to be using generative AI. So when we're thinking about an application, why would we try and separate these out into two totally separate categories of things when the person who is responsible for making sure that overall application is up and running and is doing things correctly is going to want to see how all the models are operating in context. Now, there's also an aspect, some people have been talking about LLM ops as it pertains to just managing the sheer volume, say, of the custom GPTs like OpenAI has been talking about, which they're not technically custom GPTs, as you and I both know. Just wanted to tell the audience that it's basically just customizing a version of ChatGPT. But there's a question of, when you deploy that in an enterprise context and you have, let's say, 5,000, 10,000 users using these things that are able to create their own customized setup, who is responsible for actually managing all of that and making sure that those are used, those are accurate, and all that type of stuff? That is technically part of the idea of operationalizing these large language models, but that is not the same set of activities as monitoring how models are responding to specific prompts, checking the latency and things like that. That would probably fall more under the kind of model ops approach. So as I've been looking at, there's kind of both the model and application layer, and then there's the sort of user experience, or if we wanted to think about a metaphor for business intelligence and analytics, the layer where you're managing all the dashboards and making sure that all the data and stuff that goes into them is correct and people are using them correctly.
Gotcha. So it sounds like LLMOps should definitely not be treated as a separate thing from MLOps or model ops, but model ops needs to evolve and change. And there is this element of a meta layer on top of it that is a new capability that really is different, but you should be evolving towards that and adding that to that as part of some sort of integrated approach versus thinking of these things as two entirely distinct things applicable to separate applications.
Yeah, absolutely. And I think it's also important to recognize that we will also be using generative AI as part of the execution of model ops broadly. So bringing in things like natural language querying and whatnot to the ability. So especially if you're looking across, tens of thousands of models in an enterprise context, being able to just, instead of do a more structured query about, what models are doing what, you can write a natural language query to do that. So it'll also start to come in kind of on the user experience side as well as the model monitoring side per se.
Oh, Rowan, we could keep on talking about this. I know that there are more myths out there that we need to go in and bust in this, but you've set everyone up extremely, extremely well for their AI journeys, and I think we've tackled really the biggest, most pernicious ones that folks believe in. There are certain other ones in there about like the size of large language models and bigger is better, but I think folks are already overcoming that one. But thank you very, very much for your time and thoughts. I highly recommend for everybody who wants to read more of Rowan's excellent research that they look at his latest Forrester report, the GenAI Advantage. And also, if you want to hear more from Rowan, please do check out our Data Science Leaders podcast episode from August on getting the most out of GenAI. So, Rowan, thank you very, very much for joining us. And thank you to our audience.
Yes, thank you, audience. Thank you, Shel, for having me. It's always a pleasure to be here. And I definitely want to second you on folks going back to listen to the August podcast as well, because I think it'll be really interesting to see how quickly the space has moved and how our conversation has changed since August. So yeah, thanks again for having me. It's always great to be here.
Thank you very much. You've been listening to Data Science Leaders from Domino Data Lab. If you found our discussion insightful, be sure to subscribe to never miss an episode. Your support helps us deliver cutting-edge content and keep the data science community informed and inspired. We appreciate every review. Until next time.